Now we come towards the center of mass. So center of mass of the different shapes of the body will be different. So we can have the different cases for the center of mass. Now system consisting of large number of particles. Whenever we use the term particles, we are referring to atoms or the molecules of that system. You can always remember that when we take a system, it is made up of many atoms. Normally 10 to the power 20 per gram material of that system. Now suppose that the particles are executing motion under the effect of some external force. The internal forces are interatomic forces. Now when we say some external force, means some force is applied on the body. So again, once more, we'll just go through with the concept. A system consisting of large number of particles and executing motion under the effect of some external force, that is the applied force acting on it. It has been found that there is a point in the system where if whole mass of the system is concentrated, whole mass of the system is concentrated, that is supposed to be concentrated, the nature of the motion executed by the system remains unaltered. When the forces acting on the system are applied directly at this point, such a point in the system is called the center of mass of the system. Now, if we take a triangular lamina, a sphere, then in case of sphere, the geometrical center is supposed to be the center of mass. In case of a triangular lamina, well, we take three sides and the point where the medians meet, that is supposed to be the center of mass. And that point where the medians meet is called centroid, and centroid divides the median in the ratio 2:1. So this fact is now coming for the next concept. In a system of many particles, the center of mass is the point in the system, which alone describes the linear motion of the system as a whole. Center of mass is a point about which the sum of the moments of the masses. When we use the term moments of the masses, we are referring to the product of the mass of the particle and its position vector, that is the radius. So that is the multiplication of mass and its position vector with respect to the center of mass of all the particles in the body is 0. So we are assuming that masses are m1, m2, m3 and their position vectors are r1, r2, r3. With respect to the center of masses, the values will be m1, r1, m2, r2, m3, r3 and we take their sum and that becomes equal to 0. Now, the next concept is written as sigma MIRI. Sigma means summation. Mi means mass of the ith particle. Ri means radius of the ith particle or the position vector of the ith particle. It means that the whole solid is made up of I particles. So their sum will be taken as the product of M and R, that is summation of MIRI will be 0, where Ri is the position vector of the ith particle, as I have explained just now, with respect to the center of mass, Mi, that is equal to mass of the ith particle. Suppose a system consists of n particles, that is n atoms or n molecules, and their masses are m1, m2, m3, and so on up to mn. And their position vectors with respect to chosen reference frame will be, say it is R1, R2, R3 and so on. Therefore, the position vector of the center of mass of the position vector, that is given as M1, R1 plus M2, R2 plus M3, R3 plus and so on, divided by M1 plus M2 plus M3. Now this can be written as summation of MI divided by summation of MI. And that is given in the integral form. That is integration of, that is position vector r with respect to dm, and divided by integration of 1 with respect to dm. Now, if the masses are m1, m2, m3 are situated at x1, y1, z1, that is, these are the coordinates in x plane, then x2, y2, z2, and x3, y3, z3, the coordinates of the center of mass in the same reference are given by. Now the figure is given. M1, M2, M3 are the masses. C is the center of mass. And R1, R2, and R3 are the position vectors of M1, M2, and M3. So, if you wanted to find the center of mass or distance of the center of mass, then it is given by function the product of mass and the distance between the particles. So, it will be m1x1 plus m2x2 plus and so on divided by m1 plus m2. Now, this can be written in a short form, that is sigma mixi over sigma mi, and that is equal to integration of x with respect to dm divided by integration of 1 dm. Now, mi means the mass of the ith particle, xi means the distance of the ith particle. Now, next thing is we have to find the center of mass along the y-axis. Means that whole solid, our calculations will be on the three axes, the x-axis, the y-axis, and the z-axis. So, the center of mass on the y-axis will be, again the same formula is to be applied, where y1 and y2 they replace x1 and x2. So, the formula will become m1 y1 plus m2 y2 plus m3 y3 and so on divided by m1 plus m2, and we can write in the short form, that is summation mi yi. Mi means the mass of the ith particle, yi means the distance along y-axis of the ith particle. So, this is divided by summation of mi, and the whole thing can be written in the integral form, that is integration of y with respect to dm divided by integration of 1 with respect to dm. Now, the same concept we have to apply for the z-axis, that is center of mass at z-axis. So, it is given as m1 z1 plus m2 z2 plus and so on divided by m1 plus m2. In short, it can be written as summation of mi divided by summation of mi. And this can be written in the integral form, that is integration of z with respect to dm and the integration of 1 with respect to dm in the denominator. Now, the figure is indicating the three axes are x, y, and z. These axes are called the lattices of the solid. And m1, m2, m3 are the masses of the particles along x-axis, the y-axis, and the z-axis. And r1, r2, and r3 are their position vectors. So, the mass m1, it has coordinate system in 3 dimensions, x1, y1, z1, and for m2 it should be x2, y2, z2, and for m3 the coordinates will be x3, y3, z3.